And if you have, say, 5 kroners and 10 kroners, and the amount you have to pay is 17, you cannot do it. So this diophantine equation has no solutions.
Now it sounds a bit too easy. Almost.
Yeah, I'm afraid you don't get the Abel Prize for paying with exact change.
So, Professor Holden, this year it's all about diophantine equations. Tell me more. What is a diophantine equation?
So, when you try to solve an equation to compute the interest on a loan or the time it takes to charge your car battery, you get the decimal number as an answer. But you round it off to an integer, say the kroner, amount of kroner, or the minute it takes. And equations where integers or rational numbers are solutions are diophantine equations.
Could you give me a simple example?
Yes, let's take one example being this room. Fire regulations give a maximum number of seats that can be in this room. But it doesn't specify the number of rows and the seats in each row. And to solve this, find the optimal solution for this, is solving a diophantine equation. Another example is if you want to buy something and pay with exact change. You have a 1 kroner coin, you have a 10 kroner coin, you may have a 50 kroner bill, and you have to find the right combination to add up to the exact amount you have to pay. In order to do that, you have to solve a diophantine equations. And if you have, say, 5 kroners and 10 kroners, and the amount you have to pay is 17, you cannot do it. So this diophantine equation has no solutions.
Now it sounds a bit too easy. Almost.
Yeah, I'm afraid you don't get the Abel Prize for paying with exact change.
So, does this have any practical significance today?
Yes, diophantine equations are at the foundation of everything we do when we have transactions on the internet and want to make them safe. So the more we know about diophantine equations, the safer the transactions we do on the internet can be. And we want to avoid people to break the codes, so we want to know as much as possible about diophantine equations.